Okay, so let's try to finish off that review. I waited on the last one because that's where the graphing starts, which is a little bit different than everything else on that review. So that's kind of why I decided to cut it and not make it to the end of that page. So let's go ahead and jump into a little bit of trig graphing. So here we go. We'll go ahead and take a look at that. Let's do this. What's that? It is lunchtime. Yeah, no worries. Okay. So yeah, so anyway, so let's take a look at our sine wave. Now keep in mind this is a negative sine wave, right? So a negative sine wave, remember, starts in the middle, ends in the middle, and kind of has this general shape. So we're going to have something like this. I'm not going to make this dotted because it's actually a sine, not a cosecant. And so we go through our process. Remember, this is the easy stuff where we put our vertical shift here, and we could say we went up 5 and down 5. You do not have to do this, but sometimes people like to go ahead and check their answers to make sure that what they're doing works. So I'm just going to type this in as I go. Over 16 and then plus 7. Notice in the calculator I had to actually add an extra parentheses to start the sine and to close both the phase shift portion and the other. And looks to me like under Windows we picked a Y minimum of 2 and a Y maximum of 12. Now, coming back over to here, notice that my phase shift is pi over 16. We've been calling that letter C sitting right here. This thing goes there. And then we know that the period should be 2 pi over B, which in this case would be the number 4. And I'm going to go ahead and make a common denominator so it matches this 16th that I have that I'm playing with here. So if I multiply by 16, I would get 8. And so keep in mind, I started here. As soon as I finished that entire period, I would land at 9 because I added those together. Then what I personally do, as I just define midpoints, is I add and divide by 2. So 1 plus 9 is 10, and half of that is 5, pi over 16. 5 and 9 is 14, half of that is 7. And then right here, it would be, I guess, 1 pi over 16. Nope, 3 pi over 16. Be a little careful there. Now, the problem, we're kind of done with that, but let's just finish off. So my curve started at pi over 16, and it finished up at 9 pi over 16. So again, I just put those values in. I can tell I made a mistake there. And if I hit graph, I have made my calculator into this window. And so I should see a box that perfectly fits one negative sine wave cycle. So it kind of shows me that I did okay. But there's a couple other things that I could do to confirm that answer. Because that didn't take me very long. But I really like this trace button right here. And if you hit trace, it kind of doesn't seem like it'll do it, but it actually has buried in it the ability to ask for questions. Like I could ask the calculator right now, just type pi over 16. And what my calculator is going to do is it's going to go find the value of that graph at pi over 16. And notice it says it's at 7, which matches my curve. Or I could ask, say, 7 pi over 16. By the way, you can move that off to the next desk over there. You're fine. I could ask for 7 pi over 16, and it says 12, which again matches my curve. So I know I did okay. That's just a nice way to confirm our results. Now, this says let's find all the maximums. And so there's many, many maximums. So one of those maximums happened at 7 pi over 16, didn't it? Right there, that's a maximum, the top of the curve. But then since the period is pi over 2, you can see that right here. If I move over pi over 2, once, twice, 3 times, etc., I would hit a new maximum. So anyway, I want to make sure that I don't over-explain, but I'm going to factor the 3 out. I didn't have a vertical shift, so I had a 0 here with an amplitude of 11. Cosine waves start and end at the top of the box with these quarter values. I'm going to grab my phase shift here of minus pi over 6. My period is going to be 2 pi over b, which is 3. So making a common denominator is 4. And one of my favorite things is we always are dividing this box into 4 pieces, 1, 2, 3, 4. So anytime you have 4, that makes it really, really nice, and you'll see that in a second. But if I added 4 pi over 6, this side is 3. Right in the middle of those, negative 1 and 3 is 1. Here is 0, and here is 2. And you can see that negative, 0, 1, 2, and 3 pi over 6. It's just a really nice, simple, easy pattern that we have. And again, if I wanted to type it into my calculator, I could do so, right? So tangent, this is our, tangents. I always look at tangents and go, oh, scary time. Those tangents are harder than everybody else, but we'll hang with it. Again, not technically called an amplitude, everybody. This is called a vertical stretch factor. Tangents don't have amplitudes because it's not the standard wave. We want to remember that tangents shape-wise have asymptotes on lefts and right edges. Tangents like to curve up if they can, so we're just going to curve like this. Try to make your tangent look like it actually honors those 2 asymptotes. And since we don't like anything attached to x, I could do that. And that looks almost silly to write it that way because I really didn't do anything. But what it leads me to see is that the phase shift this time was 0. And remember, tangents was the dumb one. I told you that. Tangents are the ugly one. That's where the phase shift goes to the middle of the box. And in this case, the period, remember, tangents and cotangents have that pi over b instead of 2 pi over b. So pi over 8 would just be 8, which is actually sweet. 8, that's easy. So if the entire period from here to here is 8, then from here to here is just going to be 4. So I'm going to move over 4 and backwards 4. And that's going to leave these values. And now I have everything that I could want on my tangent. And again, I could graph this on my calculator just like everything else. But all I would see is if I put it in there is I would just see this, which still, if you see that, then it kind of tells you did okay. So my asymptotes happen at negative 4. And then if I move over 8, I'm going to have another one and another one and another one and another one. That's why I did the K thing. So finishing this off, we're almost done. Factor out that 1/8. Remember, dividing by 1/8 is like multiplying by 8. So this is kind of weird. You could check that with the distributive property, but that's kind of how that plays. Now, one of the bummers about secants, remember, is it's a reciprocal of a cosine. So you don't have to draw this. I've always found it helps me. So I, in a dotted fashion, draw a cosine wave in here to remind myself that the secant is its reciprocal. So I know that this graph is going to have a vertical asymptote everywhere where the secant crossed the middle. So I don't know what those are quite yet, but I know they're going to be there. I also know that this is going to have a wave going down, and these two are going to be coming up because, remember, it always touches the top of the box. But we're kind of getting there a little bit at a time. My phase shift left edge was 2 pi. My period, now this is kind of weird. My period is 2 pi over 1/8. But if I flip-flop and multiply, that's 16 pi. So if I started over here at 2 pi and I moved over, these numbers are kind of getting mixed up between the two equations, but this one is 2 pi, and if I moved over 16, I would be at 18 pi. Right in the middle of 2 and 18 is 20. Cut that in half, it'd be 10. Well, that's that minimum value right there, right in the middle. 2 and 10 makes 12. I cut that in half, I'd have 6. So x equals 6 pi is the equation of the asymptote. Notice that I actually put an equation there, x equals, whereas I put a number here. Right in the middle of 10 and 18 is 14. Oh, I should have written that right here, shouldn't I? This is 6 pi and 14 pi. I didn't need to write that here. I already had a place for it. Now, in terms of where those minimums are, I can see that there was a minimum that happened right here at 10 pi. So the minimum happened at 10 pi, but it also happened again if I moved over a period. So 16 pi k. So if I added a period to it, I would get another and another and another minimum. Now, I'm going to skip and do number 16 because it kind of fits into my thought process a little bit better because I'm doing graphing. So this is, again, that thing that we've been calling curve sketching. I love cosines just because it's easy to see the top and bottom of curves. So keep in mind, I'm looking at this as a cosine wave, and in fact, a positive cosine wave, but we'll also model it as a sine wave. And I see that the bottom of this box is at -2 and the top of the box is at 4. I can see that right here. So that would put the middle of it at 1. So here's 1. So it looks to me like the graph, no matter what, got shifted up 1 unit. That's pretty cool. That's easy. And I can see from here to here, its amplitude was 3. Okay, let's see what else we have. On the box, I can see if this is 0 and pi over 2, this guy is negative pi over 4, which means the cosine got shifted over pi over 4. And if this is 3 pi over 4, then what I can see is from here to here is pi. But if the period should be 2 pi over b, remember 2 pi over b, and it's this, then the period, I needed 2 here, so 2 pi over 2 gives me that. So my cosine wave is done. I have everything that I could use for my cosine. I just need to figure out where the sine would start. So I personally go like this, right in the middle, and I locate a place where the sine looks pretty, and I think it looks pretty right there, which happens to be at 0. So I'm not even going to need a phase shift because this looks like a nice, pretty sine wave. In fact, if I took my highlighter out, what does this actually look like? You're going to notice that that looks like a beautiful little negative sine wave. And no, you don't have to put the 0 there. I just am letting you know that I did consider it. And then dead last, the very last thing that we have is I want to know, when is the tangent this answer? Well, again, we already did the unit circle. So go to the grid that you had, and what you would notice is that the tangent is √3 over 3 at pi over 6. If you look at the graph, that's what it is. But it says I want to rotate backwards. So let's see. If I rotated backwards, A, S, T, C, and then again, I'm rotating backwards because it says between -2 pi and 0, that's backwards. It has to be a negative √3 over 3, so it can't be here or here. So I either rotate down pi over 6, or if this was 6 pi over 6 to get into this quadrant, I need one more. So this would be in the fourth quadrant rotating down, or the second quadrant rotating down. Those are the two values that would result in that tangent being negative. And that kind of finishes up that review. So hopefully that's helpful to you. See you back in class.